Poland, Krakow, pani profesor Małgorzata Wilk. And now topic microplastic.
Do you hear me? So actually it will be a talk about that we are doing something about it. Because we are engineering, and the team which is here shown was working on experimental methods to remove microplastic. And but at the beginning, the outline of my presentation, I will tell something about microplastic and its presence, and short introduction and about its characteristic. Then I will talk about the material we were trying to extract microplastic, its sewage sludge, and the method which we use to do it. Okay, it's going. Okay. So coming back. Then I will show some methods we used for its identification and show some results and conclude my talk. So, as was already said, there is a cycle of contamination in the system, and microplastic also is everywhere. And we eat in packages of plastic. We drink from plastic bottles. So it is around us everywhere. And if we eat and if we inhale, it's in the system and it's going around and cycles. So when it can be found in human body, this is only one slide. I think the next presenter will show more about it. But that I wanted to underline that microplastic indeed is a problem. And I would like mostly focus on that, how to remove that problem from the wastewater treatment when it accumulates, in fact. When I was doing this presentation, firstly I also wanted to find out when it can be found in the body. So it can be found everywhere. There is a lot of research, recent research, which confirm this statement that unfortunately the microplastic accumulate in some parts of our body. But what is interesting, how much we can find the microplastic. So it could be from a very few particles per gram in lungs to several thousands microgram per gram in the brain. And of course, it causes a lot of problems in the body, in all organs. We don't know yet how to do it, or maybe next presenter will show us about it. But for sure, when it goes to digestion system, it comes to the wastewater treatment plant, and then it's accumulated in sewage sludge. And just to show the recent research I was doing with my PhD student, where we exactly and what kind of amount we can find the microplastic according to the data which are found in literature. The highest amount of microplastic was found in China, which is a really big market for microplastic, so that's why probably there, and also there, the microplastic is a hot topic now. But why sewage sludge? Sewage sludge usually, this is the byproduct from wastewater treatment plant when we want to clean the wastewater, and then we get also the more like solid part with sewage sludge, which has to be disposed in some places. Usually the disposal is in agriculture. If it goes to soil, it comes to our it comes to our body as well. So we can say that there is high risk of secondary environmental pollution when it comes to the soil with sewage sludge, which is usually used as fertilizer. And as you see, this is quite a lot, almost 50% of sewage sludge in Europe disposed in this way. So what can we do as engineers during the wastewater treatment processes? Usually there are some physical, biological and chemical methods which help us to remove many different contaminants as well as microplastic, but the problem is that microplastic are very, very tiny. So only up to 10% can be removed. The rest, up to 99%, is accumulated in sewage sludge. And then, as I said, it goes to the soil usually. So it can be stated that sewage sludge, unfortunately, is environmental storage. Sewage sludge is, when it's pre-treated to be stabilized and, let's say, safe for agriculture and approved by the documents, because it has to meet some criteria to be used as fertilizer, is also called biosolids, just to know that there is some kind of different names for this. So what is the most difficult with microplastic detection, in fact? It's extraction, which involves a lot of different procedures and methods to find out how much and what kind of microplastic we have. Without the identification, this is not a problem. We use microscopy, spectroscopy, chromatography or thermal analysis, and if we only get the samples, it can be find out how much we have. So I will introduce here the process which I'm very enthusiastic about. This is hydrothermal carbonization. This is a method which is dedicated to highly moisture content feedstock, and this is we could say this is like cooking in pressurized reactor. The temperature range is not so high, 180 to 150, and for sewage sludge, depending how it was processed on wastewater treatment plant, and the optimal condition up from 2 to 4 hours. And what is the most important, water, which is contained in the feedstock, is a catalyst which initiates the change of reaction, changing and causing the transformation of this sludge. The sludge is very difficult to be, the consistency of sludge is very difficult. We cannot filter the water from it. After this process, we got the hydrothermal slurry, which is in fact the solid particles suspended in post-processing liquid, and a bit of gas, which is usually CO2 and nitrogen. But when you see on the graph, there is really a high amount of byproduct post-processing liquid. Unfortunately, all contamination from the solid goes to the water, so the problem is there. It's highly organic, and it gives the possibility to produce biogas. So we tested also this kind of process. But what this process gives us? It gives us, first of all, a very good dewaterability. We can filter the solid particles from this water very easily. And also this kind of temperature ensure that it will be well disinfected and hygienized. And the other problem which is solved, that we have even 5 times less solid sewage sludge, let's say pre-treated, yeah? Usually this is the problem for wastewater treatment plant, because they have to pay to dispose this material. So to reduce the amount is reduce the money spent for its disposal. And the other benefits are microplastic removal, pharmaceutical removal, or its degradation in the system. Also, if we think how to dispose the solid, the hydrochar, the solid particle, and if we think about using it is for gasification or combustion processes, it can be stated that it has to be dry before. And this is a huge energy demand for this process. So after the hydrothermal carbonization, after this transformation, we need 5 times less energy for drying. So this is also a good point for this. Before we started to test it, we did the review, and indeed in the recent literature you see 22, 25, 24 people are doing this research. They are trying to find out and use this method to reduce the microplastic. So indeed there are some proofs that it can be effective, even 90% of total reduction of different microplastic, depending on the condition of the process. So the plan was simple: extract microplastic from sewage sludge, and then from hydrochar, and then identified them. As usually, plan is simple, but it's much more difficult to do it. With the hydrothermal carbonization process, we don't have this problem, because this is the topic we are doing 10 years, so we try to find and to know everything from experimental point of view, and this is our setup. This time we try to find out how the how the temperature, increase in temperature will affect the microplastic, and based on our experience, we decided to do it for 2 hours. So the highly challenging and the most difficult one is the extraction of the microplastic. It's very, very tiny. It could be less than 5 millimeters, because according to the definition, the microplastic is less than 5 millimeters. So there are different fragments, different shapes, different colors of this microplastic. But how to do it, not to remove during the procedure some microplastic. Of course, we had to use everything which is not plastic made. So the equipment has to be glass made or metal, something which will be not affected, which will not affect our tests. And also we decided at the beginning to lyophilize the material to avoid the evaporation of microplastic in the system. So what was done, it was the steps of our procedure included density separation, digestion of organic matter, and filtration of fiberglass. It's easy to say, but it has to repeat it very, very often, and sometimes it takes weeks to get the final material. Because if we have the material stored and ready for identification, this is the question to find out the optimal condition for this identification, but this is much easier than extraction. And also the repeatability is very difficult, because if we take part from that side and the other side, it's always completely different, and the statistics is challenging also. What we got, because this is the beginning of our project, we just got the money in June, so we had started first test even before to find out if it will work. So the first results shows, as you see, the blue bars are before the process and the red after the process. And the number of microplastic in that particular conditions, 200 Celsius degree and 2 hours, indeed shown that there is some decrease. But what was also very important, that after the process, we mostly had black microplastic, white, colorful, they disappeared. So the carbonization caused these changes. There are some results of optical microscopy, just to show you that different microplastic shape, character has in the sewage sludge. And it also depends on the place when the sludge were collected, because this particular material was taken from the Żory part of Poland, and there are some facilities which are processing polymers. So these sewage sludge are completely different from the Płaszów in Kraków, for example. So it also affects, so it's not so easy to find out, because let's say from the research point of view, sewage sludge is very nice material, because every time you take the sample, it's something different. But for overall, it's very difficult to find out the method which will be effective for everything. Okay, some identification by Raman spectra, just to show that there are different kind of polymers inside, like polystyrene, polyethylene, polyterephthalate ethylene. But after the process, we got only two. So the chemical structure has changed. So it could be stated that during this process, this molecular transformation was done, and we got at the end carbonized particle, and which consists of short chain carboxylic acid and its derivatives. And also just to show how the temperature affected the amount of the microplastic extracted, and also to show, I wanted to show you here on the CM images that the structure is completely different. The higher temperature, the more degraded structure of microplastic was found. So to conclude, we think that the method is good, because this is like the method is done to process sewage sludge, and besides this, also remove microplastic. And this is the beginning of our project, so I hope we will collect more and will test more places, more optimal or more conditions, and we'll have more information for you, even how to do it, to remove it from sewage sludge. Thank you very much.
Thank you for this very challenging methodology, and we'll discuss afterwards.